and RBB dash is called as base spreading resistance. So it is between the base and the actual base and virtual base B dash. So you will be joining the base by a wire, and this wire will have some resistance. That resistance is modeled by this quantity RBB dash. It is called as base spreading resistance, and the value is very low. It is in the order of 100 ohms. So it represents how much resistance you have in the base side of your transistor. Okay, so next resistance is RB dash E. This RB dash E is between the virtual base and the emitter terminal, and the typical value is 1 kilo ohm. You can consider this RB dash E to be similar to HIE of your transistor. So you have studied in H parameters, we have the input impedance, right? HIE. So this RB dash E can be related to HIE of your transistor. So the total input resistance, if you see, it is addition of both these two will be in series, right? So if you have if you measure the input impedance, the RB dash, BB dash, and RB dash E will be in series. So that will be the total input resistance at the side. So I can write HIE is equal to RBB dash plus RB dash E. When you compare these two things, RB dash E is very larger compared to RBB dash. So I can write HIE is approximately, I can write HIE will be equal to RB dash E. Okay, if you consider the value wise. Otherwise, it is addition of RBB dash and RB dash E. Okay, this is the exact formula, and what we have written is the approximate value of HIE. Okay, so then next resistance we have RB dash C. It is between the base and collector, and its value is very large in the order of 4 mega ohms. Okay, so this you can see it is somewhere here. It is the present between input and output, so it will act like a Miller resistance. Same way, this C B dash C is present between the input and output, so it will act as Miller capacitance. We have studied about Miller's theorem in the last class. Any component present between the input and output terminals of a device can be decomposed using Miller's theorem. Here we have two such elements. One is resistance, one is capacitance, which is connected between the input and output of the transistor. So these two are the Miller devices in the circuit. And C B dash is the diffusion. For base emitter junction is forward bias, so that forward bias base emitter junction will always have a capacitance. So that is given by C B dash E, and its value is very large, in the order of 100 picofarad. It is very high. Okay. Next one is C B dash C. It is in the output, in the output side, collector based junction is reverse bias. So reverse bias junctions will have a reverse bias capacitance that is quantified by C B dash C, and it will have a value of 3 picofarad, which is very small when compared to the forward bias characteristics of your diode. And RCE is the output resistance, which is in the order of 80 kilo ohms. Generally, whatever load you will be having, you will be connecting the load parallel to your RCE only. And finally, the current source GM-BP-E, and GM is going to be the trans conductance of the transistor. See, for any transistor amplifier, I can measure 4 parameters. One is voltage gain, output voltage by input voltage. Next one is current gain, output current by input current. Trans conductance is I by V. The formula for G is I by V. So it is output current by input voltage. And trans resistance is given by capital R, which is V by I, so output voltage by input current. So you can measure all the 4 parameters for a transistor amplifier. So depending on what the configuration the amplifier is working, one among the 4 will be dominating. Okay, so all amplifiers will not have values for all the 4 types of gains. So one parameter will be dominating for one specific type of amplifier. So these are the formulas you should know relating your H parameters and high frequency parameters. So GM will be equal to IC by VT, and VT is your thermal voltage. It is 26 millivolt at room temperature. RB dash E equal to HFE by GM, and RBB dash equal to HIE minus RB dash E. RB dash C equal to 1 by GB dash E, which is RB dash E by HRE, and GCE equal to 1 by RCE equal to HOE. So this table relates your H parameters and hybrid pi model parameters. So just in case if problem is asked when H parameter is known, you can even calculate what is the hybrid pi model parameters using this conversion formula, which is listed in the table. This is for your reference.